Welcome in. We're going to look at a question that was requested on Wyzant having to do with the statistics problem of normal distribution and finding the probability. So let's look at what this question is all about. It first says, suppose 4-year-olds in a certain country average 2 hours a day unsupervised, and that most of the unsupervised children live in rural areas considered safe. Suppose then that the standard deviation is 1.4 hours and the amount of time spent online alone is normally distributed. We randomly survey one 4-year-old living in a rural area. And I don't know, I guess when they mean survey, they mean observe. And so we are interested in the amount of time the child spends alone per day. It says to find the probability that the child spends less than 1 hour per day unsupervised. So, what is the chance that this single child or a single child, right, spends less than an hour per day unsupervised? They also want us to write out the probability statement, which we'll definitely do in the process. And of course, answer the question of what is that probability? All right, let's take note of some things because you do want to be aware of the context and the information provided. So it says in the very beginning, which is usually the case, in the first sentence, 4-year-olds are being studied basically in a certain country. And it's either the assumption or maybe it is the case that from the people in that country, 4-year-olds usually spend about 2 hours a day. So maybe this is like gathered information from a lot of different people in that country to speak on the unsupervision of 4-year-olds. So we're going to call this the population. Basically, this is telling us the population of study are 4-year-olds. The interest here is the number of days that these 4-year-olds are unsupervised, and therefore the average value is the population mean, right? What we would also call the parameter. Another parameter in this case is the standard deviation. And this is really important because while maybe at this point in the course, if this is the case for you, right, you're just getting started with normal distribution and probability. And then later on, you're going to see there's other formulas that deal with, different, say, context or other pieces of information, right? And the reason why I say that is because later on it says in a very distinct way, they survey one 4-year-old. So we're looking at a single 4-year-old child out of the entire population. So we're not dealing necessarily with a sample, okay? We're dealing with straightforward parameters and an individual value related to that population. Okay, so let's make those notes, right? This is the population mean, that's the parameter, and this is our population standard deviation. And this is going to relate then to the symbols that we would use. Notice that for population mean, we tend to use the Greek symbol mu, which is that U with the longer stem, right? And then we have the lowercase sigma value or sigma symbol, also Greek letter, that looks like an O with an extra stem on top, right? All right, so the question at hand, right? They want us to find the probability of this child spending less than 1 hour unsupervised in a day. We're not going to worry about the per day part. Honestly, we don't have to worry about that. But with that being said, we now have things to look into and to find the chance of, the likeliness of. Now, how does this relate in normal distribution and the curve? Let me scroll down a little bit so you can see that. Okay, so to the left, I actually went ahead and drew the curve, which I recommend doing this anytime you're dealing with normal distribution or really other common distributions. Draw yourself a picture so you can see what you're dealing with. All right, we have for a normal distribution, which they tell us this particular data set or population is normally distributed. We can draw the bell-shaped curve where it's symmetrical around the mean, and we have the area shaded in, okay? So this is what it looks like. All right, note too that you can also give a notation anytime you have a distribution that is normal. You can write it as n of the mean and standard deviation of it. Okay, so this is denoting it as a normal distribution with those two features. Okay, and so now we're going to move into how do we set it up and solve it. So this is also going to relate to the calculator you use, and then or also maybe if you use a chart. But I will take note of something real quick before we jump in. It does say to round your answer to 4 decimal places. And you may wonder why is that? It's probably because they may expect you to use a calculator. So if you use some kind of technology or a calculator, whether that's something like a graphing calculator, scientific calculator like the TI-84, TI-36, those are really common ones. You may use Excel, okay? You may use some online calculator. I'll show you two in this video. But if you use the chart, which let me show you what that looks like. All right, actually, I'm right on it. Okay, here's the chart. This is in a set of formulas that I have in charts as well. So here is the Z chart, what we call the standard normal distribution, the standard score, Z, okay? So this is the chart which shows you all approximated values, whether that's the Z value or the area that a Z score would be associated with. Okay, so this is where you wouldn't have to worry about rounding, and I will show you this as well. Okay, but I'm going to use a calculator in this video that I actually don't use that much. I just found it online, which you could too. Okay, and there's another one that I actually use that I'll showcase, but I tend to use the TI-84. All right, if you have that, or if your course has recommended that, which I also recommend, then you definitely could utilize that. And I'll make a note of that when we get to probability. So that's why you see that up there, okay? So with the given information and the question, let's see what our probability statement looks like, okay? So it's gonna always look something like this. You have P, right, representing just the word probability. So P of X less than 1. So how do I know to write it like that? Literally because it says in the problem less than, and that translates into an area to the left of whatever the value is as the boundary. So we look back at our chart here, we see that the boundary for that area is 1. So the area that we're looking for is associated with this range of values, okay, up to the value 1 in this population distribution. So that is going to be our probability statement to represent what we're looking for. And we're going to see how do we get there. This is my little flow chart I like to use, or not flow chart, but concept map, right? Or just to map out where we start, where we're ending up. So we're starting with the X value. What they want is an area or probability, as they put it, that is going up to that value. Now, the major way to get there, especially if you use this chart, let's say you had to use this chart or you're familiar with using it, is to use the Z score. That is like your mediator, basically. So keep in mind, it's not the answer. It's just a way to get to the answer. If they ask you, what is the Z score? Obviously, that would be your answer. But just keep in mind, when we go to look for the Z score, which will happen in a moment here, okay, you'll see a formula that should look familiar. That's going to be the key to finding the area, because that's a large reason as to why we have the Z score. Okay, so we're going to do that first and foremost. All right, let me actually say number 1. We're going to find the Z score. So we're going to literally take the X value that they give us and convert it into a Z score. All right, so again, this formula should look familiar. We take the value that we are given that's part of the population, or could be a part of the population, and subtract the average from that and divide that difference by the standard deviation. Okay, and in doing so, we get an equivalent value, in a sense, the contextual equivalence. Z is to X, right? They're going to obviously be different numbers, but in terms of the context, they're going to represent the same thing, right? So 1 minus 2 over 1.4 is our setup. Feel free to pause the video if you want to just calculate that real quick for yourself, okay? Or check it once I show you the answer. So when we do 1 minus 2 divided by 1.4, okay, we get a pretty long decimal. Now, depending on if you are familiar with the chart or not, most cases we're going to see the AZ score rounded off to 2 decimal places. And it's probably because of the chart. So you're going to see me do that, but feel free to round off further out to make it a little bit more precise, okay? But there's our z-score. The z-score associated with this x value is negative 0.71. All right, so I can illustrate this with the chart as well. And notice I am literally copying and pasting the same curve with the same area, okay, that we're looking for. All I'm doing is I'm switching out x for z. All right, so from your, I love how I cannot change my my pen. So let me just close that out and open it back up. This is a usual thing for me. So I appreciate you bearing with me on this. All right, so all right, so from your learning about the standard normal distribution, it's pretty much the same numbers every time. And the major numbers that you definitely see time and time again related to it is what is the mean and the standard deviation. So the mean is always 0 and the standard deviation is always 1. So therefore, we're going to see here the z-score for the mean is 0 there. We found the z-score for that x value. And notice it definitely aligns with how the original normal distribution looks. The z-score is to the left of the 0, right, because it's negative. And the area that we're going to find is going to be the same area to answer the question, the original question and statement. Okay, so now that we have that, we usually use either a chart or technology to find the probability. Okay, so I'm going to rewrite the original, but then set it equal to its equivalent contextual form, which is the probability of the z-score, or probability of all z values up to negative 0.71. Okay, now this is one of the, I would say, easier cases because there are 3 different cases of finding the probability in a normal distribution, okay, when you're using the z-score. So this is to the left, whereas there's to the right and in between. When it's to the left, you really only have to find the value once and you're done, okay? I think it would be good to start with, yeah, I'm gonna actually use the calculator. So this is a calculator I literally just found online, searching up normal distribution probability calculator, something like that, okay? And just take note of how you have to plug in stuff. So just like with a lot of other calculators, and I think this includes Excel, or if not, you just type it in. Oh no, there's two different functions, and one of them is defaulted to the features of a standard normal distribution. So you can see that here as well. The mean and standard deviation is already set as 0 and 1. That tells you that this is in terms of the z-score. These are z-score values as well. 1.96, right, is associated with the area 0.025, okay, whether it's above or below. So keeping that in mind, all right, we're going to choose the one, I guess you could say, like, type of area that we're looking for, right? And we're going to choose below because below is associated with less than. And then we're going to replace it with our z-score. So I'm just going ahead and showing you how you can do this in the calculator like this. Okay, so if you have the TI-84, it can operate the same way. So there's the answer, right? And I'm just going to mention a few other things before we close here, but we're already done. That's what's great about this type of area. When it's to the left, it automatically gives you an area that you can take away with. And I would say the reason why, not I would say, but the reason why, is because a lot of these calculators are following after the chart, right? Always remember, calculators, they came after somebody did all the work. They're just speeding up the process or automating the process, right? So somebody already did this work and it shows in this chart. So these charts for the Z-score is showing you areas defaulted to the left. Okay, so always keep that in mind that when you use a chart or any other calculator, it's going to give you an area to the left unless you tell it to give you an area to the right. And that comes with other a different type of setup. Okay, now that's what we get approximately. And we'll go ahead and make sure I got that written in right. So let me get that for you. Okay, that is it. All right, now let me just briefly state that if you use something like a TI-84, okay, a handheld calculator, all right, the function that you would use will spell out like this. And you find this by clicking the second, which is your shift button on the key on the keyboard. And then you're going to click vars, which takes you to the distribution menu. Okay. So normal CDF, C standing for cumulative, so we're going up to a certain value. It's going to take in the values that is just like here, what we see already typed in and what we typed out ourselves. Okay. Let me fix that. So the first value that you'll see, you'll have to type in, whether that's a menu that has fill in the blank, or you have maybe like the TI-83, where you have this pasting on the main page, but you're gonna see it written out the same way. So after the normal CDF and open parentheses, you have -1 E99. Just know that that means -1 times 10 to the 99th power. This virtually means infinity, because keep in mind that the normal distribution curve is continuous probability or of continuous probability. And so the curve, the graph, it continues on forever and ever into infinity, right? So that's going to represent that. And then we're going up to the value that we found for the Z-score. All right, so here's our lower bound, which is into infinity virtually. And then the upper bound, it goes up to negative 0.71. And then finally, we have the mean and the standard deviation. Okay, now I will write out real quick what it actually comes out to. This is what you could say is the exact value, and it may keep going, but it's 0.2388. My apologies. I just realized am I sharing? I'm actually confused. Okay. I almost thought that I wasn't sharing at first, but I'm still sharing. Okay. So the value is 0.23885199, right? It keeps going, but you can see how we have it rounded, right? We round out to 4 decimal places. So with the 5 there, it looks like using that first calculator, we get 0.2389. Maybe it's 0.2388. Let's check real quick here in our chart. Okay. So if you're familiar with this already, this should definitely look like a review. Okay. If not, we're going to just find the 2 parts that make up this Z-score that we have. So we're going to split it up into 0.7 negative and then 0.01. So here's negative 0.7 and then 0.01, and we see where they cross. So there it is again. Okay, so I've shown you 3 different ways to get to the same answer. All right, and there's one more calculator I'll quickly show you. This one is rcbuddy.com, one that I've used a lot, and it's been really helpful and supportive. So in this situation, what you would have to do is, after you've selected or you've you've set up what type of distribution area you want to look for or thing you want to look for, then you have to type -99999 to kind of help it think it's infinity. All right, and then we type -0.71. And just like this calculator, you're going to get a graph shown up too. which is really nice. You see a picture of what's happening. And there's the value again, 0.23885. All right. So I hope you found this video helpful in explaining and showing you how to work through it. And let us know if you happen to have any other questions in the meantime or later on. All right. See you around.